Here's a problem from homework number 15. We're told that a boat capsized in a lake. Oh no, means it sunk. Um, or flipped anyway. Hopefully it didn't sink. Everybody made it out okay. But what did the boat company do? That boat company was the boat was carrying 7 passengers, and the reason the boat company decided to let 70 passengers on is because they knew that the boat could hold 10,010 pounds. 10,010 pounds. And they assumed that the mean weight of people was 143 pounds. So they divided this by 143, and that's how they came up with the number 70. They said, all right, 70, we can fill this boat just with 70 passengers. Because of course they want to fill in the boat with as many people as possible to make as much money as they can. So, but maybe there was a problem with this assumption, and that's what we need to look at. So let's take a look at the question. Part A here says, assume that a similar boat is loaded with 70 passengers. 70 passengers, and now we know the weights of people are normally distributed with a mean of 179.6 pounds and a standard deviation of 39.5 pounds. Find the probability that the boat is overloaded because the 70 passengers have a mean weight of greater than 143, because we know if there's 70 people on that boat and the average weight is over 143, you're going to exceed your 10,010 pounds and the boat will sink. All right, but look here, our mean is 179, so 143. Let's mark it on our graph. I made this template just to save a little time, but as you can see, I've labeled everything and want to draw your attention here to the X, which is not the weights of each person, but the mean weights of 70 passengers. So we know we're using the central limit theorem here. What does the central limit theorem tell us? It tells us that the standard deviation changes. The mean stays the same, but the standard deviation will change. In fact, let's quickly figure out that new standard deviation. It's going to equal the original standard deviation of 39.5 divided by the square root of our group size, which is 70, right? If you punch that into your calculator, you're going to get a new standard deviation of 4.72. All right, so that's the actual standard deviation we're going to use for this problem. Otherwise, it's the same old thing we've been doing for a while now. So now I can see that 143 is way below the mean, way, way, way below the mean. A lot of standard deviations below. I'm going to write it way out here. These are always just approximations, visual aids, but here is where x equals 143 pounds, where the average weight for the 70 passengers is 143. We're going to have to find a z-score for this value, which we'll do in a minute. But we're asked to find the probability that x is greater than 143. This is where the boat sinks. If we exceed 143 pounds per person, then we cross over that 10,010 pound limit that the boat can take. All right. So the question is, what is the probability? That is our question mark. What is this area under the curve? Find the probability. So in other words, find the probability that x, or the weight of the 70 passengers, the mean weight of the 70 passengers, exceeds 143 pounds. Okay? And that's what we're solving. All right? Well, the first thing we need to do is change x into a z. All right, so if probability of x is greater than 143 is the same thing as the probability z is greater than what? We need to standardize this value. Well, we know that z equals the x value, which is 143, minus the mean of 179.6 divided by the standard deviation of 4.72, not the 39.5. Plugging that into our calculator, we come up with, oh wow, minus 7.75. We are almost 8 standard deviations below the mean. Wow, that's a lot. All right? In fact, you can see that it's basically 100%. There was almost 100% chance that it was going to sink. But just to go through the math, so this is the same as z is greater than negative 7.75. Remember, our z-table can't do greater than, it can only do less than, so this is the same thing as 1 minus the probability that z would be less than or equal to negative 7.75. and that's going to equal 1 minus. Now, if you go to your z table, you're going to see that you can't even find negative 7.75 on the z table. The biggest you can find is 3.5 standard deviations below the mean, and that's already 0.0001. This is even smaller than that, 0.00000 on for so I don't even know. There could be a one-way out there, but it's so far out it's insignificant. So in fact, the probability that x is greater than or equal to 143 is equal to 1. Or 1 point, I think they want 4 decimal places on the problem, so you got to plug in those 4 zeros. But basically, there was a 100% chance this boat was going to sink. So their assumption was not very smart. Okay, let's look at the second part of this problem. All right, so we're back to our original template here. Part B says the boat was later rated to carry only 16 passengers. Why 16? Well, because they decided the load limit they're dropping it down from 10,000 pounds down to 2,784. So 2,784, and they also now decided that the mean weight was going to be 174. They wouldn't let anybody, if the mean weight was exceeded 174, then they wouldn't let anybody on the boat. So then when they did this, and they adjusted these numbers, they came up with a new limit of passengers of 16. Okay, so that's how they came up with the 16 passengers. All right, that's not so important other than just to explain where it's coming from, but what we actually have to figure out is what is the probability that X, or our group, will be greater than or equal to now 174 pounds. A couple things we need to change now. This is no longer the mean weights of 70 people. This is now the mean weights of 16 people. And because this is still greater than 1, we still have to use the central limit theorem. So we're going to have to find that new standard deviation, which will equal the 39.5 divided by the square root of 16 now instead of 70. We've decreased the number of passengers. And doing that on your calculator, you're going to get a new standard deviation of 9.875. Right, so that's the standard deviation we'll be using for this problem. All right, now let's mark this x value on our graph so we have a better visualization of what we're doing. 174 is below the mean. I'll just say it's about here. Okay, this is where x equals 174. And we want to find the probability that this is greater than. This is again where the boat sinks. All right, this is where the boat sinks. So again, we have to find this probability. This is our question mark. All right. All right, to find the probability x is greater than 174, the first thing we have to do is standardize it. That's the same thing as probability z would be greater than what? Well, let's find that z-score. This is standardizing this 174 into a z-score. Z equals the 174, the x, minus the mean of 179.6 divided by our standard deviation of 9.875. Plugging all that into our calculator, we get a standard deviation of negative 0.57. So just a little over half a standard deviation below the mean. I could probably have drawn it a little closer in, negative 0.57. Okay, writing it here. All right, and as you know by now, there's no greater than on our z-score table, so I'm going to rewrite this as 1 minus the probability that z is less than or equal to negative 0.57. Go ahead and go to your z-table and figure out what that is. I see that it is, if you work that out, the probability is 0.2843. Right? So that 0.2843 is actually this space here to the left, 0.2843. That's this space to the left. So what do we want? We actually want this space to the right, so we're going to have to subtract it from 1. And what we get is 7.7157. All right, so this area here is that 0.7157. That's this area under the curve. All right, so that's roughly 72% chance. So there's still a 72% chance that if you fill the boat with 16 people and a mean weight of 174, having a mean grade of 174, there's still a 72% chance that your boat's gonna sink. So I think they still need to make some further adjustments. All right, good luck with that one.